Right, so this is another question on Bayes' theorem, and it's about a disease called tuberculosis. It's called TB for short. And this is a disease that's caused by a bacteria, and it usually affects the lungs. Now, TB is a dangerous disease. It's got a 50% mortality rate, which means that if it's not cured, then there's a 50% chance that the person would die. Now, the standard way of detecting TB is to take a chest X-ray of the person. So you take an X-ray of the chest, and the doctor can see whether or not the person has TB by looking at the X-ray. Now, this is a very reliable process, but it's not wholly reliable, which means that sometimes it can happen that the X-ray says one thing, but the reality is something else. So just how reliable is an X-ray for detecting TB? Well, we are told in the question that the probability of an X-ray saying yes, this person has TB, given that the person actually does have TB. So these are my two events. X is the event that the X-ray says yes, the person has TB, and T is the event that the person actually does have TB. Well, the probability of X given T is 99 by 100, which is actually quite good. It's 99%, so it's got a 99% hit rate, right? But it can happen that the X-ray says yes, the person has TB, when the person actually does not have TB. So T prime is the event that the person does not have TB, actually does not. So we've been given the probability for this too. So the probability that the X-ray says yes, this is a false positive, is 9 by 1000. So this is a false positive, right? So this is 9 by 1000. So it's a small probability. It's just 0.9%. That's less than 1%, but it's not zero also. So we've been given these two probabilities. And then what we are asked is that if it's known that in a given town, 1 in 600 people has TB, which means that if I pick a random person in the town, then the probability that that person has TB is 1 by 600. And if I take this random person and give him a chest X-ray, and the X-ray turns out to be positive, and the X-ray says yes, this person has TB, then what's the probability that the person actually does have TB? So this is what we're being asked. So this is a different probability from X given T. So this is T given X, and that was X given T. So we are asked to find out what T given X is. Now, this is a conditional probability, so obviously our first thoughts go to Bayes' theorem, right? And what Bayes' theorem says is that probability of T given X is equal to the probability of X given T multiplied by the probability of T divided by the probability of X. So this follows straight from the definition. This whole thing over here follows straight from definition. And what we need are values for the three terms on the right hand side. These two in the numerator. So we need values for this and this and this. So if we have a look at it, so in the numerator we know everything. We have been given probabilities for X given T. That's over here. And we know what probability of T is. So that was over here. So the only thing that's left to be found is probability of X. So we don't know what probability of X is. So let me do that on a new page. So X is the event that an X-ray says yes, the person has TB. So that can happen in two ways. The X-ray says yes, the person has TB, and the person actually does have TB. Or the X-ray says yes, the person has TB, and the person actually does not have TB. So either a person can have TB or cannot have TB, and the X-ray could say yes in either case. And this could be rewritten as probability of X given T multiplied by probability of T, and this could be written as probability of X given T prime into probability of T prime, right? Now we know this term and we know this term. We were given this term, this was the false positive, X given T prime, this was the false positive. So the only thing we don't know yet is this term over here. So this is the term we don't know. So what's probability of T prime? Well, either a person has TB or it does not. So probability of T prime is simply 1 minus probability of T, which is equal to 1 minus 1 by 600, which is equal to 599 by 600. So we got this missing piece, and therefore we can now calculate probability of X, and then we'll plug that into the base formula we had written earlier, and then from there we can get probability of T given X. So let's do that now. So probability of X is equal to probability of X given T was, I think, 99 by 100 multiplied by the probability of T, which was 1 by 600, plus probability of X given T prime. This was a false positive, so this was 9 by 1000 multiplied by probability of T prime. We just wrote that down. That's 599 by 600. So I can simplify this. I'll just take 1 by 600 out, and what I'm left with on the inside is 99 by 100 plus 599 times 9. That is, well, something. So 599 times 9 is 5391 divided by 1000, which simplifies to, and you can actually do this on your own. You can check this calculation on your own, because I don't want to make this question about the calculation. The calculations are rarely important. It's the concept that is more important. This comes down to 6381 divided by 1000. So this is probability of X, which means that we've got the last missing piece. Px was the last missing piece that we needed to calculate probability of T given X, which was equal to probability of X given T into probability of T divided by Px. So we got the last missing piece, and probability of X given T was 99 by 100 multiplied by the probability of T, which was 1 by 600, and this whole thing has to be divided by this expression over here. So that's 1 by 600 multiplied by 6381 divided by 1000. So this comes down to 1 by 600, 1 by 600 cancel, and this boils down to 990 by 6381, which can be reduced to 110 divided by 709. Now I have not done any of these calculations in my head, so don't freak out. I used a calculator, and you can check the calculations on your own. But the answer to our question, which is that if you take an X-ray of a person, of a random person in this city, and it shows that it's and the X-ray says yes, this person has TB, then the probability of him actually having TB is 110 by 709, right? So that's the answer to our question.